This presentation provides an overview of Chapter 8, Part B, in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Iman Hakiki and Thomas Hurdle, and published by Springer. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover a portion of Chapter 8, which is on computation and baseline, efficient methods for solving a large system of equations for projection and scenario analysis. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, and discussing the gridded data and parameters. In this chapter, we focus on computational challenges and solutions. Quantitative geospatial equilibrium models hold immense potential, but translating these ideas into practical, computable models is challenging. The core issue lies in representing complex realities with large systems of equations, and nonlinear relationships between economic factors can further complicate matters. Balancing the need for detailed spatial representation with computational tractability and real-world policy relevance becomes crucial. Unfortunately, the high dimensionality of these models and strong interconnectedness often limits the use of parallel computing, making them computationally expensive and difficult to troubleshoot. As a result, these models can become black boxes, where the internal workings aren't easily understood, reducing interpretability. The Simple G framework tackles the computational challenges of large-scale, geospatial economic analysis by leveraging the capabilities of GEMPACK, a software suite known for its efficiency in handling complex economic models. Simple G employs two key techniques: condensation and linearization. Condensation reduces the model's size by utilizing the economic theory underpinning the model to solve first for prices, and subsequently obtain all of the gridded outcomes based on these prices. Linearization approximates nonlinear relationships, making them computationally easier to handle. This combination allows for faster simulations and improved model troubleshooting, potentially paving the way for more robust and insightful geospatial economic analysis. Simple G is able to handle large and geographically heterogeneous analysis through techniques like condensation and linearization. However, effectively communicating these results requires innovative tools. For this, we've created user-friendly interfaces for less advanced users to run and visualize Simple G models by leveraging the cloud computing power of the GeoHub, which enables wider access to these computation tools, making them more accessible to everyone. Secondly, for more advanced users, we've initiated tools that allow users to tailor reports and visualizations to their specific needs, which empowers users to look into the model's outputs and extract the most relevant results. If you're interested in learning more about the computation of gridded economic models, please review Chapter 8 in the Simple G book, where you'll learn about condensation, decomposition techniques, computation in the cloud, how to build a baseline, and how to create scenarios. Here, you'll find additional readings and references you might be interested in further exploring. On this slide, you'll find the link to the Simple G webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 8b. We encourage you to explore the other companion videos that accompany the book on the Simple G webpage.